Welcome to part 6 and the heady delights of structs. In this video I'm going to introduce structs and show you how you can define them and use them in the simplest example. So here's the introductory slide. As stated, C does not have classes, which is what we use to structure data in Python and Java. It doesn't have those. It has a loose, very weak approximation called a struct or a data record. And you can think of that as being like an object without methods. Let's declare one. I'm going to declare a student object, which has a name and an age. Only we call them structs, not objects. So this looks like the following. Struct, open curly brace, and the fields of the object are a name and an age. I can't initialize them here because this is just essentially sort of like a type definition, and now I can declare the name of the variable of that type. So I've got a global variable, student, which has those two attributes. I can now initialize those down in my main program where I'm using that example by saying the student's name is, for example, Charlie, and the student's age is 16 or something. I've got one student, not very interesting, can't do much with it, but you've noticed the notation. I use the dot notation as we did in both Python and Java to plug in attributes into that. You can think of this as an 8 plus 4 byte global lump of memory, 12 bytes in total, which has got some internal structure to it, which is why they're called structs. So far, so good. Let's have another one. In order to have another one and to make it the same type, I have to extend the struct syntax a bit by a kind of horrible C-type notation, which adds what's called a struct tag after the word struct. Those two together constitute a type. This is not very pretty, but that's how it's done. So with that type in mind, I can have a second student called student, and I'm going to call this one student 1 and this one student 2. So we'll now go and clarify which student I'm talking about, and I'm going to have the second student 2 name is Fred, and student 2 age is 16 or something different, age 2 is 23. I've now got two students, they're unrelated, and it's not very interesting yet. What would make them interesting would be to have some pointers. Let's have some pointer fun. In order to have pointer fun, we need to declare a link, as it's called, from one student to the next. So what I'm creating here is what in COSC 122 was called a linked list. And this is the real guts of linked lists. You're seeing them as actual explicit pointers in C. For those of you who haven't done COSC 122, just hang in there. All will hopefully become clear or not. We'll see. I want to point it to the next student. In order to do that, I have to use the type and the value, with the star at the end to indicate it's a pointer, and then next. So now I can link the first student to the second one. Student1.next is the address of the second student. And the student 2 doesn't have a next because there isn't any more students left. So I'm going to say student2.next is null, which is always used to indicate the end of a list. To skip a little bit ahead through the lecture notes to show you what just happened, this is the picture with different names and ages. Student 1 has a name which is a pointer to a lump of global memory containing the string literal. Similarly for student 2, a string literal. The ages of the students are both there as integers, and the last field of each record, each struct, is a pointer to the next student. And this last student, student 2, doesn't point anywhere, null pointer. Okay, having done that, I can now write interesting functions to loop through a linked list and print all the students in it. Let's have a go. I'm going to write a void function, print students, which is going to take as a parameter a const, because I don't want to modify the list of students, const student struct student star student. So it takes as a parameter a pointer to the first student in the list. And then it loops through the list of students. And this takes a while to get used to, but the way you write the code for this is just while student is not equal to null. If you're really lazy C programmer, you can just write while student, because testing against 0 is kind of the same as just using the variable by itself. While we haven't hit the end of the list, we have a valid pointer. Let's printf using a string with the age in brackets afterwards and a new line, student pointer name, student pointer age. Now, you might think that should have been a dot. I made a mistake, and it could be a dot. I'll come back to that. could be a dot with certain restrictions. And I want to move the student on to the next one. So the student now is the next student in the list. That iterates through all the students. Let's just first of all watch it run, and then I'll come back and explain those pointery things. I don't seem to have done anything because I forgot to call it. Let's call print students, passing in a pointer to the first student in the list. Now you'll probably have to stop the video and parrot this code. Better still, run it on your own laptops to see what's happening. There it is. It prints the list of students in the linked list. Now, let's have a look at this notation. Student pointer name seems a little bit odd. There's another way of writing that, which maybe is clearer, maybe not, and that is to say the dot notation on the student name. So star student is a student. Remember, we go indirect through the pointer to get the actual student, and then we look at the actual student's name. So I can run the code that way as well, but generally it's nicer to use the syntax with an arrow here, which is equivalent exactly. It says go in, use the student as a pointer and get the name, rather than use the student as the object and extract its name field directly, which is what dot does. So that's kind of where these two slides got to. To summarize some of the key aspects, the syntax is a bit weird. It consists of the word struct, a tag, and the list of the fields of the object in braces, followed by a list of any variables of that sort. In this case, I've only got one. I could have other in here to have multiple students, but the later ones I declared using the type notation. So this thing is acting as a type. Note that they're not references, as you might be used to in Python or Java. These are allocated wherever they're defined. So this is globally, so you get a global struct object. In the next video, we'll look at putting them into the main function itself. And I have a style convention which says the structure tag should be always distinguished as a special type of identifier by adding _s. And when I want to access the fields of the object, I use the dot notation if I have an object, or the pointer notation if what I have is a pointer to the object. In the next video, I'll look at how to make this example a little clearer by using some type defs and putting things into the main function. I hope getting away from dreaded global variables. Thank you for watching. Bye.